So let's put this to practice now. We have the second derivative test, which is going to help us find out what the curve of the graph looks like. So we can use the original function to find things like the domain and the range, any x-intercepts, any y-intercepts. We can use the first derivative to find out where the graph is increasing or decreasing and where the maximums and minimums are. Now we can use the second derivative to find out where it is concave up or concave down and to determine any inflection points. And it's really easy how we do this. First, we're going to take the second derivative. So take a minute and do that. Now that you've done do that, now that you've done did that, yes. We want to find the critical values of the second derivative. Now, I know a critical value is defined as all the points on a first derivative that are equal to 0 are undefined, but critical value for the second derivative is the same thing. Find out where that second derivative is 0 or undefined. And I found 3 of them, plus or minus the square root of 2 or 0. Then we're going to make a sign chart, just like we did for the first derivative test. Now it's important, once you have your sign chart, make sure you plug any experimental values into the second derivative. If we want concavity, we need to use the second derivative. So I plug in something like -10, and I realize that gives me a negative number. Then I pick out something, gosh, I don't know that exact value, but I think -0.1 would do. And that gives me a small number here, and wow, it gives me a small number there. I think I have a negative times a negative. Positive 0.1 here. And maybe 312 there, because that's just a ridiculous number, but it's so big I can kind of tell. So this tells me that, yes, this interval is concave down, this one's concave up, concave down, and concave up. This allows me to answer my 2 questions up top as such. So now we have our solutions. Inflection points occur when concavity changes. So it best be going from negative to positive or positive to negative. But where do we get our y coordinates from? For the actual height, that's what the original function tells us. The actual height, looks like, oh my, I didn't leave enough room. Negative 0.2371 or positive 0.237. If I did those in the right order. I hope so. I think so. And then finally, the intervals where it's concave up are already written down here. That's why I like doing the sign chart this way. The answers are already there for you. You can spot them as you go. Let's do one more example of this. We'll pick out one that's not an easy polynomial. Well, this one looks fine. It's really not that hard to do the derivatives on this one. Thought it was kind of nice there. But it is interesting because of the fractional exponent. So go ahead and take the first 2 derivatives and get back to me. And these are great derivatives here. What you need to do, though, is find those critical values. To find those critical values, in this situation, it might actually help you to factor. Remember, when we factor, we find the common, numbers. That seems pretty easy here. Awkward numbers, but it's still pretty easy to find the common ones. But then we always take out the smaller value or smaller power of the x values. And what I mean by that is, in a normal problem with nice integers here, we factor out, well, there's 6 x's here, 4 x's there, and 2 here. But we're going to factor out the smaller number because that's all that we can take out. If the term with the smallest degree is x squared, that's the most that we can take out from each term. So when we go back and look at this, which one is the smallest x value? So believe it or not, it's actually easier to leave these derivatives possibly written as a power, and then you can say, wow, -2/3 is the smallest value. When I factor this out or divide it out, I'll be left with x to the 1/3 minus 1. I'll show you that again one more time in another minute, but this is how we can find the critical values. This is going to be undefined if I let x equal 0, because this is really in the denominator. That's not going to work. You can't divide by 0. To solve this one,
a little bit